So before we start looking at definitions and those kinds of technical things, I want to look at an example here that will help to kind of illustrate what we're talking about with inverse functions. All right, so I've got two formulas here. One of them gives you the distance traveled by a car going 60 miles an hour based on how long it's traveled. And the other one, you notice it does the reverse. It gives you the time traveled based on the distance. All right, so let's get some numbers here. Right, I'm going to do times and distances. And so let's just pick a few numbers. Let's keep it simple. 1, 2, and 4. And so those would be hours. If you put those into our formula, 1 hour corresponds to 60 miles. 2 hours corresponds to 120 miles. And 4 hours corresponds to 240 hours. Okay. Now let's try the same thing with our time function. Right? I'm going to give it distances, d values, and I'm going to get time values back out. So let's pick some distances. Let's do 60, 120, and 240. No, I did not pick those at random. And let's calculate the times, right? 60 miles is 60 divided by 60. That's 1 hour. 120 miles is 120 divided by 60. That's 2 hours. And 240 miles is 240 divided by 60. That's 4 hours. Okay. Compare these two tables. Right? Notice that they are the same, just flipped over. Right? The first table has 1, 2, and 4 for the x's, if you will, the first column. The second one has 1, 2, and 4 for the y values, the function values, the second column. The same is true of the other column. The second column here is 60, 120, and 240. The first column here is 60, 120, and 240. This is what we mean by one function being an inverse of the other. Right? The x values and the y values between the two functions are literally just reversed. Right? Before we are done with this conversation about inverses, you are going to be so tired of hearing me say, switch the x's and the y's, because that really is, in a practical sense, how we're going to work with functions when we're talking about inverses. All right. So I've got a practical, there's a formal definition here. The function that assigns every value of y to x is called the inverse function of f, right? So it literally just goes backwards, where the original function takes an x value and assigns it to a y value. The inverse function pairs the numbers up in the other order. And this is how we write it. And I got to talk about that for a second because there's a lot of potential for confusion here. That -1 is not an exponent, right? It's not. This does not mean, not highlight big solid strokes here. This is not 1 over f of x. Right? F inverse of x, this just means the inverse of x. And if I were reading this, you could say the inverse of x, or you could say just f inverse. Either one is fine. All right, so let's see how this works with some numbers. I have a function here. Again, we'll do some with formulas in a little bit. We're going to get to that. But for now, just to kind of keep things down to an easy to work with scale, I'm doing these with these tables. So the original function f assigns -2 to -9, -1 to -2, and so on. So my question here is, what does the inverse function do? Well, if the original function assigns -2 to -9, then the inverse assigns -9 to -2. If the original function assigns -1 to -2, then the inverse assigns -2 to -1. See what I'm doing? Right? I'm literally just taking this first column here and repeating it in the second column. That's really all there is to it. All right, now I made a big deal about we need to know what one-to-one functions are, right? And this is why, right? Only one-to-one functions have inverses, right? And I've got an example here to illustrate that. We actually saw this function. We talked about this in the last lecture and saw that this is not a one-to-one function because some y values, 4 for example, get matched up with more than one x value, right? It's not one-to-one. So look at what happens if we try to create the inverse of this function, right? If I do the same thing I've done before and just flip the sides, right? Well, you can see now that the sides are flipped, we have a problem. Now I have values in the first column that are being assigned to more than one value in the second column, and that's not allowed for a function, right? So if a function is not one-to-one, then when you try to invert it, the y values that are being assigned to more than one x value in the original function will become x values assigned to more than one y value, and that's not allowed. All right, so I've got a few examples here, situations for us to work through, just kind of practicing with this. So the first question is, suppose that f of x is a one-to-one function. I'm going to repeat that a lot here, right? Just because that guarantees that the inverse we're going to be talking about will exist, right? And I'm told that f of 3 is equal to 4. And my question here is, what is f inverse of 4? Well, remember, 3 here is an x value, and 4 here is a y value. And all I've done is I've switched them, right? I put that old y value in the x position, if you will. And the result here is going to be 3. It's going to be the old x value. All right, my second one, suppose that the point 1, 5 is on the graph of f. What point must be on the graph of f inverse, assuming it exists? I should throw that in there, right? Well, remember, and again, I told you you're going to get tired of this, the inverse function flips the original function. So if 1, 5 is a point on f, then 5, 1 must be a point on f inverse. So I've got another function here, right? This time I've defined it by giving ordered pairs instead of a table, but that's fine, right? There's lots of ways to define a function. And first I want to confirm that this function is one-to-one. Then I want to give its inverse. Okay, well, you can see it's one-to-one because every y value is unique. If I had a y value that appeared twice, we'd have a problem. I'd have to say it wasn't. All right, so what is its inverse? Well, on the last question, we saw an individual point, and to find the inverse, we flipped the x and the y. Well, that's all I'm going to do here. I'm just going to do it with all the points. So it's going to be 5, 2. That flips the first one. 3, 1. 6, -2. And 12, 6. And that's it. There's my inverse. There is my inverse function. So this would be f inverse. All right, so I've got one more here. And I believe this is actually the same function, right? Same set of ordered pairs. What I want to do is I want to give the domain and range of the function and its inverse. All right, you got to think about what you're being asked for here. All right, you're being asked for the domain and the range. So first, I know my answer is going to be sets because the domain and range are sets. And I've been asked for these sets for the function and its inverse. All right, so that's 2 sets for 2 functions. So in the end, I'm going to have 4 sets in my answer. All right, so let's see how this works out. The question didn't name this. Let's call the original function f. Right, so then the domain of f is all of the x values, -2, 1, 2, and 6. And I'm being very much the mathematician and sorting them as I go along. If you just copy them, they don't have to be in order. If you just copy them in the order they were in the list there, that would be fine. Then the range of f are the y values. That's going to be 3, 5, 6, and 12. Okay, now I want to do this for the inverse, right? Well, look, I'm going to shortcut this enormously. Remember, the domain is all the x's, right? Well, remember, the x's and y's switch. So the x's for the domain, the x's for the original function are the y's for the inverse, but the y's are the range. So the domain of f is equal to the range of f inverse. And the reverse is true, right? The y values for the original function became the x values for the inverse. So the range of f is equal to the domain of f inverse. Right now we're just kind of switching the x's and y's wholesale, as it were. All right, so now we've got we know what inverses are. We've got a little experience working with them. And then in the next lecture, we're going to kind of take the next step and talk about how we can determine if two functions are inverses of each other, and then how we can find the inverse of a function if we're given its formula.